Welcome. In this video, we continue our exploration of the limit definition of the derivative. We are going to compute the second derivative of the same function, x squared minus x. And we already computed the first derivative, f prime of x equals 2x minus 1. Now, since we want the second derivative, we need to find the limit as h approaches 0, not of f of x plus h, but at f prime of x plus h minus f prime of x minus h. Do you see the difference? Last time we did not have these primes here since we just wanted the first derivative. There we are. But now since we want the second derivative, we work with f prime of x. So this is the limit as h approaches 0 of 2 times x plus h minus 1 minus 2x minus 1 divided by h. And this is this first derivative evaluated at x plus h. And here we just have our original derivative function. So this is the limit as h approaches 0 of 2x plus 2h minus 1. All I've done is distribute that 2 minus 2x plus 1 divided by h. Now, 2x minus 2x, well, that's 0. As is negative 1 plus 1 is also 0. So we're left with the limit as h approaches 0 of 2h over h, which is the limit as h approaches 0 of 2. This is just 2. That tells me that the second derivative of this function is equal to 2. Now let's go ahead and graph this, and let's graph it along with our already existing sketch of the original function and the derivative function. Okay, so I made a little space making this smaller and kind of moving things around, but overall we have the same thing. Here is our original parabola in green, the line representing the first derivative in blue. And now let's go ahead and sketch the second derivative in purple, f double prime of x equals 2. Well, that tells us this is a constant, so this is just a horizontal line this way, intersecting y equals 2. So this is y equals f double prime, this is y equals f prime, and here we have y equals f. So notice that our original function compared to its derivative, when it had a negative slope, was below the x-axis. When it had a slope of 0, the derivative crossed the x-axis. And when it had a positive slope, our derivative was above the x-axis. Similarly, let's take a look at this first derivative function compared with the second derivative function. The slope of this blue line here is positive in the entire way up. So you'd be going uphill if you were climbing these steps. This is an uphill climb. So this slope is positive. It makes sense then that the derivative function of the first derivative is above the x-axis. That tells me that this function is growing at a constant rate, and that rate is 2.